All right, guys. Well, thanks for coming. When Lisa said this is a technical discussion, she wasn't kidding. So this is going to be a pretty in-depth discussion. I promise you there won't be any marketing stuff. Like what it says on the T-shirt. So what are we talking about? I mean, we've been hearing X.509 certificate authentication upstream from time to time. And when we were at the hit chat, people pop into the hit chat room and sometimes in the mailing list asking, how do we support certificate-based authentication? And then answer that, yeah, it works, right? But I don't think anybody has gotten do a prototype on it and shown how it works end to end. So, about 3 weeks ago, our product management comes in and asks us, hey, one of our customers asking for X.509 certificate authentication because their security team only allows common access card authentication. Is that possible? So basically, before we go sign a contract, let us engineering guys to test it out, make sure it works. So what we did is we take a couple weeks to do some POCs and then see if it works. And then so this is the session that presents our findings on that POC. So as it turns out, X.509 certificate authentication from the browser is fairly trivial, but there are some gotchas that you need to work out. As far as using CLIs and the middleware, that requires some code changes, which Sam's going to talk about later on how that works. So like I said, this is a pretty fairly technical discussion. So if you go too fast, please just raise your hand and stop pressing it. We can slow down and explain a little bit further. So we're going to do 4 parts. First, we're going to talk about what is certificate-based authentication, and then we're going to go into why do we need it, or why do we want it, what are the advantages in using that. And then we're going to have a few demos on how it works. And then we're going to go into some deployment scenarios. When it comes to Keystone authentication, there's no one-size-fits-all. There's a lot of options available, and there are pros and cons to each option. So we're going to go through some of those, and hopefully it will help you make some decisions in deployment. So how many of you guys are familiar with SSL, or two-way SSL, certificate-based authentication? So this is mostly going to be a review. So if you ever using a browser that talk to your bank or talk to, when we enter that credit card, you see the green bar across the browser, that means you're using SSL. And in most scenarios, your browser is only required to validate the certificate coming from the service providers. In that case, your bank, or whatever merchant that you provide credit card information to, and then the information is encrypted through the secure channel, which is through SSL, which is called secure socket layer, or transport layer security. So they're both the same. Because, TOS is the latest version of SSL, if you will. And then underneath the hood, X.509 certificate is what makes SSL happen. And X.509 certificate is basically your digital identity. When I talk about identity, I don't mean a person. It could be a person, but in the digital world, an identity is basically a set of trusted attributes which uniquely identify who you are, right? When I say you, it could mean you, the person, or it could mean the device, or it could mean a application. So it's basically a set of attributes, a trust attribute. And then how you trust those attributes is through cryptographic means. So basically, you have the public and private key pair. For those of you that are familiar with cryptography. And then anything that's encrypted with a public key can only be encrypted by a private key and vice versa. And then your public key is the one that you share. Unlike SSH, for example, when you have a shared key. But although certain types of SSH do have the, I'm sorry, SSH you have the public key there as well. So your public key is usually certified by a certification authority. And then what it does is that certification authority would digitally sign your key and bind your key to a set of attributes. And I can show you what it looks like in a moment. And think of a certificate as analogous to your driver license or passport, where it's a piece of legal document that you use. And in the case of two-way SSL, it's mutual trust. You validate each other's certificates. And that can be done by using the set of authority that you trust. And you're going to hear the term when you open up your browser and look into your certificates. You're going to see things like trust scores or certification authority and things like that. Those are the ones that you trust to issue certificates. And certificates and keys and so on are part of this overall public key infrastructure. Basically, public key infrastructure is a system which utilizes certificates to achieve these properties such as confidentiality, integrity, authentication, and non-repudiation. And here's what your certificate looks like. So the picture on my left is the one that the screenshot from the browser. So you go to your browser certificate store and you click on any of the certificate, and you're going to see it displays the content of the certificate. Usually it contains the subject, which is a set of attributes that has been certified, and then the issue by, which is the identity of the name of the certification authority, and then it's going to have a validity which contains not before and when it's expired. So each certificate has its own validity period, and then it has fingerprints and keys and so on. So the picture on my right is the one when you run OpenSSL. It will print out the guts of the certificate in a easier to read format. So I highlight them in the inside the red rectangle. So one is the issuer and the other one is the subject, and there are a bunch of numbers and letters. The first one is the public key that's been certified. And then there's a bunch of extensions of the certificate that you can dictate what that certificate can do. For example, can you use it for signing? Can you use it for authentication? Can you use it for encryption? And so on. And why do we need it? So we have a bunch of use cases. Like I said before, the first one is that we often hear from you look on the HP OpenStack team. So we often hear from customers that, hey, my environment already has digital certificates. Right? Like in the case of HP, we only have Class B certificates installed in our browsers, in which we use to authenticate into the HP internal applications. Right? So you don't need to carry more passwords. And when you sign on to some of the HR applications, we can use certificates. And when we deploy OpenStack, it would be nice to reuse those certificates to authenticate to OpenStack rather than just carry a bunch of passwords around and memorize all of it. And the second use case, which is the big one, you cannot sell our products to some of the government customers like the Department of Defense, where they mandate the use of Common Access Card, or CAC. For those that work in the security industry, you're going to hear that a lot. We deal with government. And it turns out those Common Access Card is using certificates, right? And then the private key is stored inside the physical card. And card readers next to the computer. And when you authenticate to the Department of Defense website, for example, you basically stick the card in and then use PKCS11 to read that the key and certificates off that card and use to establish the SSL connection. And then the third use case is interesting because when we deploy OpenStack, it's not really a greenfield deployment because when you deploy OpenStack, it has to fit into the environment. So most of our users, when they use an OpenStack, turns out they already have a corporate directory which manages all the users, right? Like Active Directory. When you work with your ETAR applications, you really authenticate to the corporate outlet, which is in most cases Active Directory. So in that case, they don't want to manage users in Keystone. They want all the users to stay in Active Directory. In that case, Keystone would just become a proxy to their identity, to the Active Directory. So we would delegate the authentication out. With one small problem, right? OpenStack requires a set of service users. Those users used for the OpenStack services to communicate with each other. Things like Nova user, Swift users, and so on. And you're going to see those when you see the Nova config files, and Swift config files, and Swift proxy config files, and Glance configs, and so on. And those are the ones. So those users use for multiple purposes. One of them being using to authorize the token validation call to Keystone. So the OpenStack API is protected with tokens. So whenever you need to request a service to the OpenStack services, you need to have authentication in XOR token head. And the services are deployed with Keystone running. Keystone middleware running. Keystone token middleware is specific. So when that middleware sees the token, it will call back to Keystone to validate the token and find out what that token is authorized to do. In order to validate that token, because the token validation is a privileged API call, so the service will have to independently authenticate themselves. It gets themselves a service token to use to authorize that call. So, but if I manage all my users in LDAP, I would have to create those service accounts in my corporate, which is pretty painful because the users that exist in a corporate directory, they are physical users, right? They have employee IDs and a bunch of other stuff. And in order to create those users, you have to go to a new set of workflow, which in some cases, may not work for some customers. So in that case, it would be nice to, not to use those service accounts at all, rather than just using certificates, because you only in the production environments, those service communications are already protected by SSL anyway. Why not use it for authentication to the application as well? And the other one is that someone, I'm not sure you're aware of this, someone at some point filed a security bug against Keystone. Basically, wait a minute, someone knows my service user password, and they will log in Horizon. That shouldn't happen. Right? How can I prevent a service user from logging into Horizon? So currently, there's no way we can prevent that. But with certificate-based authentication, since those service accounts doesn't necessarily need to exist, they will no longer be able to authenticate into Horizon unless they also have a private key. Which should not happen because the service account should stay within the control. And the last one is interesting. One of my colleagues, he was doing support for our customers, and then they go through their config files as part of troubleshooting. And then when they scroll through the config files, wait a minute, there's some nice passwords in there for my users, and that's a big no-no. So usually when your support guys deal with the customer, you go to a share screen and look at the environment. And if you're not careful when you scroll through those config files, you could show them passwords and so on. But with certificate, you don't have to put any sort of passwords in config file. because the certificate private key just lives in the file system and protected by the file system unless we can hack into the files. Those are pretty secure. So that's the added benefit of using certificate-based authentication. There's no password. And you could even argue that with certificate-based authentication, you could make automation much easier, right? Because with automation, your scripts have to read passwords of files. Those passwords, those security policies require you to rotate those passwords fairly often, 3 to 6 months or so. But for certificates, it can stay there longer. You don't have to rotate your certificate sometimes in a year or two, because brute forcing attacking the certificate is much harder than brute forcing a password. And also, the devices are becoming more personal now, right? You have your personal laptop, your PDA, your phones, and all that. All that only has a certificate provisioning. And why not make use of it? Right? Why not? There's no point of carrying, memorizing the passwords. So, we were at RSA conference at the Cloud Security Alliance Summit. The message we keep getting over and over again is that password is legacy. We should be moving on from passwords. Because you look at your smartphone, they allow biometric authentication. And the phone already has a unique certificate there to identify the device. And the last benefit of using certificate is that you could, using the certificate to log on to multiple clouds. Let's say you have multiple regions or multiple clouds. You could use the same certificate in the browser to be able to log into all of them. Now, like I said in the beginning, so there are 3 scenarios that we did a proof of concept on. And the first one is to be able to log on to the OpenStack through Horizon. Turns out this one's much easier than we thought. So there's no code changes. So there's all configuration hacks that we did. It's based on WebSSO. The flow is pretty much exactly the same, except there's a couple differences, which I will show you in a minute. And then we also did a proof of concept, using middleware that talked to Keystone for token validation. And in that case, we completely removed the service account. So there's no password in the middleware configuration. You just need to configure the certificate. And there's a review currently pending, so if you guys want to see this feature, you want to use it, make sure you go review that. And then the last one is using OpenStack CLIs to authenticate to Keystone. And that required a new plugin, which is a Keystone OR plugin, which Sam implemented. And there are a couple of patches that we currently have internally that we will be submitting after today. Now, Horizon login, how that works. So if you look at the Horizon flow, for those of you that done the WebSSO federation configuration, you should be pretty familiar with this flow. So first, when the user hit the Horizon landing page, there's a drop down which lets you select which authentication mechanism to use. One of them is X509 SSL certificate authentication. So once you select that option and click log in, what Horizon does is that it will return an HTTP redirect back to the Keystone endpoint, which is protected by a two-way SSL. And then between the browser and Keystone, there will be a SSL two-way SSL handshake happens. And if everything's authenticated, assuming the browser checked out Keystone certificate and Keystone checked out the browser certificate, Keystone will then run that certificate's attribute for mapping, which maps the user to a local identity. So that identity can be ephemeral, which means the user does not have to exist in Keystone. You just assign a temporary account in the federated domain. Or it could be mapped to a local account, which an existing account. So the mapping is fairly flexible. So I can show you how that's done. And if you go to the mapping, then Keystone will issue the token back to the browser with an embedded JavaScript, which tells the browser to talk back to Horizon with the XO token in the header, and then the browser will hit Horizon with that token. And Horizon basically does this thing the rest of the way. So if you look at the bottom half of the flow, it's exactly like as if you would log into Horizon with the username and password. Basically, first you go list all the projects that the user have access to, and grab the first project off that list and rescope that token, and then boom, you log in. That's pretty much how it's done.
Question.
Yeah.
Sorry, I can turn on from the. On. Sorry.
Would you better to use the Apache HTTPD? Apache HTTPD?
Yeah, the endpoint, I mean, this is assuming Keystone is running behind Apache ModWSGI with ModSSL enabled.
So this is assuming that you are using Apache.
Yeah, so, right. Yeah, so I'm going to show you a couple scenarios. One is that SSL connection go through a load balancer. When SSL is terminated, and the load balancer or the HA proxy, I mean, proxy, keep using HA proxy because our PLC is based on HA proxy, but the load balancer could be any load balancer. It could be a hardware balancer that you get from some hardware vendor, it could be a dedicated one, or it could be anything that can terminate SSL and it would convey the peer certificate information to the backend applications. So I'm going to show you how it's done with a direct Keystone connection as well as through a proxy and load balancer. So I'm gonna have it.
So you're going to talk about federation tokens tonight?
There won't be federation, so it's based on the federation approach. So what you get back there is a federated token, but it's no different from any other unscoped token. So it's based on the web SSL flow.
We're going to talk about Fernet tokens tonight?
No.
Isn't that the way to go?
Well, Fernet token could be another session in itself. I mean, there's so much to know about Fernet. If you guys like it, I can come back and talk about Fernet tokens in the next series of Meetup.
We were very specific on the agenda of exactly what he is going to talk about today. So and that is a topic in itself. So he's going to stick to exactly what we published. This is why I gave everybody homework ahead of time, because we have to just use the time for that today.
Okay, so you go invite him back?
Of course, we can invite him back.
Okay.
I promise you, if you're going to talk about Fernet tokens, we're going to need another couple of hours.
Yeah, I was going to say, you guys might want to meet at the bar and have that discussion.
Does HB provide beer at the bar?
All right, so here's the fun stuff. How it's done. So step number one, configure Keystone. So I highlight the changes that we have to make, Keystone configuration changes. So this first we need to touch Keystone config, Keystone.conf file. So the first one, you'll notice that there's a remote ID attribute. So that's the attribute that the Keystone Federation code at the back used to look up the service provider. So what we did is we have to create a service provider for the certificate issuer, and then we basically use that common name of the certificate issuer to identify the service provider. And the second one, we configured Horizon Federation. You should know what the second one means. The second one basically means that Keystone has to trust a Horizon endpoint. So whenever there's an authentication that's redirected to Keystone, Keystone has to know that whether it would trust that Horizon redirect or not. So this is the one that Keystone would use to compare the incoming connection. And Horizon would add its own endpoint to the HTTP parameters. I can show that in a minute. And then the last one is the templates that Keystone we use to generate a JavaScript to push back to the browser, to tell the browser to call back to Horizon. And the last changes that we have to make is that we have to use the map plugin to map the SSL attributes to the Keystone local account. So you have to, by default, if you just clone DevStack, for example, the map plugin is not supported, so you have to explicitly add that in. So notice that there's an X509 there. So X509 is when you configure web SSO in Horizon, the service provider is corresponding to the ORG plugin in the Keystone backend. So in that case, I created a service provider. I'm sorry, the protocol. That's the protocol. I created a protocol that X509 was corresponding to the map backend. And step number 2, configure Apache. So this is assuming that you clone Dev. So by the way, before I go any further, let me clarify that our proof of concept is based on DevStack. So this is based on the DevStack just from 2 days ago. So I have a Wayman script that set all this thing up. So if you guys are interested in, I can share. Just drop me an email. I can hand you the Wayman file that set all this up for you to look at. So what we did is we set an endpoint which is protected by two-way SSL. Notice that verified client required, which means that the two-way SSL connection has to be succeeded before we can proceed any further. And then the other ones are optional. Like this one depends on the security policy. You can decide the length of the certificate chain that you're able to support. And the last one is very important because when the SSL authentication is succeeded, we have to convey the client certificate information to the request environment. So the last option basically means parse the client certificate and then put it in the request environment. So this is a must. And we basically set up 2 endpoints. This one will be used by Horizon, and this one can be used by CLI for middleware. And then step number 3, like I said, you need to create a service provider, for federation, you need to create a service provider, you need to create mapping, you need to create a protocol. So all 3 of them is you need to identify an incoming service provider call. So first we create a service provider, which we use the common name of the CA to identify the service provider. But if you trust multiple CAs with the same common name, then you got to be careful. You don't want to use a common name in that case. You want to use something that's uniquely identify the certification authority. And like I said, we create a mapping. So if you're not familiar with Keystone mapping, federation mapping, basically this whole thing here, what it says is that map a SSL client certificate common name to a username, and map the SSL certificate organization to the domain. That's all it says, 0, 1. So this one will correspond to the first replacement parameter. This one corresponds to the second replacement parameter. And this one, it basically allows us to further filter the certificates. So just because you can establish a two-way SSL connection with Keystone doesn't mean you can be authenticated through federated mapping as well. So we can further filter the type of certificate that we allow for authentication. So the mapping is fairly flexible. Basically anything that is in a request environment is a fair game. But I can show you some cool stuff later. So you can restrict to the type of call. So you can say method equal to get. So you can say only the read APIs can be authenticated by certificates. Or you can say, so we have this export and forward or peer IP. You can even restrict the IP of the device to allow them to participate in the SSL certificate-based authentication. Now this one, we got to be careful. So this is very much depend on the Apache module and also the way that the certificate attributes presented to us. So for example, mod SSL and Apache, they reorder the issuer subject name, right? Notice that CN equal to sign CA in that case. The one I showed you, if you run this to OpenSSL, is the other way around, and there's no space between the commas. And this is the one that coming from HA proxy, which notice that it uses the slash instead of the comma to separate out.
Is there any way that you can automate these JSON files, or you just have to type it in? And where exactly does the JSON file fit into the scheme?
Send me an email. I'll hand you my Raven file. So it's all configured in one. All you have to do is Raven up, and everything's there for you. So whatever I talk about tonight, all available with the Raven file. You guys can just drop me an email and share that. But you asked a nice question though. Currently, to be able to create this file is finished all using your favorite editor, right? There's no way you can do it from Horizon or things like that. So for me, I just create this with my VR.
It's a lot of work.
Yeah. Well, yeah, I mean, that's a good question. I think the mapping part, we could definitely use some help to make that easier to use upscale. And the next thing we did is this proof of concept that we create the domain, the user, the project, and then assign that user some role for that project so that we can do some damage. And step number 5, you can create, at that point, everything is good to go. So make sure you bounce Apache, restart. At that point, you're good to go. And then we can just test it with the certificates. So we can do that easily with code. And if you point to that protected endpoint, you should get back an unscoped token that looks like this.
These are all PKI tokens?
I'm sorry?
PKI tokens?
No, this is a UUID token. Yeah, notice that. Well, I just showed the header. So this is Keystone v3, so the token is conveyed in the X subject token header, but this is UUID token. And then next thing is configure horizon. Now, configure horizon is pretty simple, really. So if you stand up DevStack and configure horizon with SSL enable, the top half should already done for you. And what you really need to do is just add these 3 things: enable web SSO, and then enable the drop-down menu, right? So let the user select X509 from the authentication drop-down. Now, if you also happen to support web SSO that talks to, say, Active Directory Federation services, you would have like SAML2 and OpenID Connect, OIDC, and so on. Notice that this string here is very important, so it must be exactly the same as the protocol that you created earlier in Keystone. So if this one does not match the protocol, you would not know, Keystone would not know what's authentication plugin to invoke to validate those attributes. I mean, to map those attributes. And just for fun, I created 2 regions. So this one is basically a direct SSL connection to backend Keystone, and this one goes through HA proxy. So I just want to show that it works both ways. But I can demo that in a moment. So demo time. So before we go into the demo, so I just want to walk you guys through the screens in slow motion, because there's one critical detail. If you blank, you could miss it. For those of you that are familiar with federations.
Is is a SAML to be replaced by map? And
They're two different things. SAML 2 is a protocol.
yeah, I know.
Map,
Is it
right.
being replaced by map? Map uses.
Oh, you mean the plugin itself?
Yeah.
Yeah, it will be. Map will be a genetic port plugin which maps a genetic set of attributes to a Keystone.
Is that being used right now, today?
Yeah,
So,
yeah, it's merely a name change. But don't confuse SAML 2 with map. Right? Mapping is just a genetic way of mapping one set of attributes to another set of attributes. SAML 2 is a protocol, a federation protocol that you use to talk to your identity providers to certify you. You authenticate to your identity providers using SAML protocol. So first, when you hit the Horizon landing page, there's a drop down on top which allows you to select which authentication method you want to use. Then then you select the 519 certificate. Then the next step would ask you, if you have multiple certificates in your certificate store, it would ask you which one to use. And once you select the one that you want to use, in this case, I want to use a demo certificate. Look at issue 2, CNA demo, and OE computer. Now, this is the one that I want to show you. This is the reason we have a walkthrough. Is that if you deal with Federation Web SSL to talking to EDFS, for example, you should be pretty familiar with this URL. This basically means hit the Keystone endpoint, which is either protected by SSL or protected by Melon or protected by Shibboleth and so on, right? And that basically forward you to that endpoint. If it's protected, in the case of Federation Flow, which is protected by Mod Shibboleth, for example, Mod Shibboleth will do the authentication for you to facilitate that with the identity provider. But in our case, since the endpoint is protected by two-way SSL, Mod SSL kicks in. It basically negotiates the two-way SSL session, and then pass the attributes to the Keystone backend. In that case, the X509 plugin will get invoked to map the certificate attributes to a Keystone identity attribute. The second half, the origin, that's the one that the Keystone used. Remember, so you earlier had the Keystone.conf file. That's the one Keystone they use to match up against the one that is allowed to authenticate. If the IP is different, then the authentication will be rejected. Not just IP, I mean the entire URL. So. Now, let me show you how it works. So I have a VirtualBox ready and running. So like I said, you go to Horizon's landing page. You get a chance to select online certificate, and then when you hit connect.
It's working on the broadcast, but it's not working on the projector. I have no idea. It's working here.
Do we need to redo the thing? I don't know. Like it's still working on the Hangout. It's not on it.
Mm-hmm.
No, it's okay. I think always show the screen stuff.
They really didn't want us to have this last bit up here.
Anyway, trust me, it works. No, it won't show my VM screen. Okay, let's share screen.
Meantime, Joy and Bob, you guys should meet each other. Project Barbican security needs to. So.
Okay. Okay, I can just see it from here. Switch to that only. Okay. So. Yeah. So what's my email? Okay. I think it must be my graphic driver.
Yeah.
For the
Try duplicate. Don't underestimate the fact it could be the Google Hangouts software doing this too.
Anyway, let's continue. Anyway, you guys want to see the demo? Just stop me afterward, and then I can just show you on my laptop. It's very quick.
Okay. So next.
So that's the Horizon to Keystone login. The next thing is the Keystone middleware to Keystone. Like I said in the beginning, when you hit services, it goes to middleware, and the middleware validates token. In the typical flow, like I said in the beginning, it would use the get a service token to authorize the user token validation. So that would constitute 2 round trips at least to Keystone, right? Because you need to manage that service token, and then you use that service token to authorize the call. Now with SSL, you basically eliminate the need to talk to Keystone to get a service token. In fact, there isn't any service token involved in this case. We're purely using the service certificates to authorize that call. So that feature is already landed in upstream. So what we call that is called the X509 tokenless authorization. So if you go to Keystone's repo and you search for the docs, you should be able to find out how to configure tokenless using SSL. So in this case, we'll basically using an X509 tokenless plugin to validate the user token. And then Sam's going to run you through a demo on how it works.
share tracker work?
Okay, come on.
No, this isn't working either.
You don't need the sound for the demo, Rick. I said you don't need that. Rick just wants you guys to see his picture again. That's why he keeps flashing this back.
Yes. Okay. Oh, so okay, everyone. Good evening. For coming and spending the evening time with us. My name is Sam. For the influence identity team at Enterprise. So I just like to thank you on all the pieces all the detail those things. So that my job is actually it's going to be easier basically it's going to jump in to do the demo. Before I do the demo, I like to add a bit of background to what we have in terms of the support of X509 tokenness in Keystone today. So basically, in the Liberty is we then patch, finally they patch. So basically, the patch mainly is supports the token validation on the Keystone side. However, it's still not supported on the middleware side, which means sometimes you're not able to use this X509 certificate validation yet. Until recently, we submitted a patch like one showed that earlier in the previous slides. So basically, we have a patch sitting on upstream for review. So you guys can go ahead and help us out to do the review, and hopefully we can land that patch soon. So besides the patch, we also implement 2 other patches. We believe that patch basically we works with token validation. But at the same time, it also make sense to implement something that works with token request by using the external certificate authentication. So we went ahead and then implement 2 other patches on those like onset we basically right now we keep it like local, but we'll soon to need to polish it a little bit and also add test cases like all that, and then we can submit it to upstream and for review. And again we need your support to do the review so that we can get this feature on like working on end to end. And now I'd like to jump into the actual demo. And before I do that, I actually like to show curl command. So looking at the curl command, this is familiar because it's just like the regular curl command that you can do a token request. Except you notice there's something different because we use X509 as the method, basically as the new of type that we implemented in one of our patches. So we support X509 as a new of type, and you look into the payload of X509, basically it doesn't contain any payload. This is because while you is using password as the of type. Basically, you see, the user information, user data, username, password that was info in the payload. But because we are using, X509, all those user data, are embedded, in the certificate itself. So by triggering, that curl command, so basically, of course, the user is required to present, his, X509 certificate. So that's how, the new format of token request, looks like. So the real demo is basically, simply just trigger this command. Okay, so
trust me, I just have this little script, which is the same content as what it shows for today. So basically, this will return the token. You don't care the token data, but what you will care is you return the token in the header. So that's how it works with the code comment. And another example that I'm going to show is using the OpenStack CLI. So similarly, this OpenStack CLI, it just, what you require is just like the code command. You need to, specify the X59 as the op type and presenting, the kind certificate and of course the key as well. Similarly to the code command, but this is, of course, by using the OpenStack CLI. So what this does is basically, a user is trying to request a certain list from the local service. So I also go ahead just trigger this OpenStack CLI command. So again, so basically, I just put it in a script. So what it shows, is a list of server lists from the local client. The local service. What it shows is not important, but what it does, under the hood is very important, because as you see, what it actually is doing is basically, the user is requesting a list of server. So basically, the client is talking to Keystone by presenting the client certificate and asking to use X59 computation method. So Keystone basically just validate the certificate and fill out the validation and go ahead and just issue the token. And the client turn around and then send this token to the service provider. In this case, it's Nova. So basically, Nova would try to validate this user token against the Keystone. And the important point is this: since we don't want to use password for the service provider as well. So basically, we also make changes in the local configuration file to use the X59 configuration, which it doesn't require username and password. So this basically it is what we need to specify to use in the local config file. As you notice, so we need to specify the cert file, the key file, and also the auth plugin. Auth plugin is what I mentioned. There's also another auth plugin that we implemented in one of our patches. So so that's what is basically done. And the other thing that we need to configure is in the Keystone.conf. So looking at the Keystone.conf, there are two places we need to configure. First of all, of course, we need to trust the issuer. So in this example, you see that two issuers. The first issuer is basically the issuer who issued the service client certificate. So we trust the issuer, which means that when the service client sends a request in, and we basically, okay, we know that this is trusted issuer or trusted signer, so we let that go through. The second one is the issuer who issue or sign the user certificate. So of course, just similar, similar thing happen on the back side. Keystone basically just trust this issuer and also let the user client go through. So that's the way we set up how we trust the request. And lastly is we need to specify reference, a new method that we implement is following, as we see, like curl command or the OpenStack CLI command. So as a reference, to the actual class of the new plugin. So basically, as you can see, basically, the configuration is pretty simple in order to make this to work with its formula from end to end. So that's why. Okay.
So that's what we have as far as the demo goes. The next thing we're going to talk about is probably the last thing that we're going to cover for today is deployment considerations. So there's some. Sorry. I think the graphic card is not cooperating today. Yes. So, using certificate is all fine and good, and it's beautiful and all that, right? But I mean, to use this in production, there are many considerations that get taken into account. First of all, deployment-wise, nobody's going to be allowed an external client to directly talk to your Keystone instance. Most likely, your Keystone instance are running behind a private network or proxy that is only accessible from within, and is protected by SSL and so on. So deployment-wise, if you're using proxy or load balancer, you need to figure out where you want to terminate your SSL connection. So when the external client hits your external endpoint, whether the SSL is terminated at the proxy or load balancer, or you configure your load balancer to do pass-through, which means to store the connection to the Keystone backend to the SSL protected endpoint. Or you can do the hybrid approach, which terminate the first leg of SSL at the proxy or load balancer, and then open up a new SSL connection to the back. So the benefit of the third approach is that is to prevent insider from getting the token on behalf of the user, right? Because the information from the proxy to Keystone is conveyed in the header. So anybody can get into your network, your internal network. They could, in theory, run a curl command and set those headers and so in that case, they can easily impersonate an identity from the internal networks. So the hybrid approach is probably the optimal approach of all three. And then operational-wise, we need to figure out how to manage those certificates, right? Certificate manage. The hardest part of a PKI or any SSL certificate-based authentications manage those keys and certificates. You need to figure out whether in case of common access card, the certificate would be state card, key state card, use the drivers and so on to access the certificate. And then, you have to figure out how to provision those certificates, right? I mean, how, if the certificate is compromised, you figure out how to revoke, the private key is compromised, you figure out how to revoke them. And in some cases, the security policy may dictate you rotate those certificates every year or 2 years and so on. And then, you can think about different classes of certificates in operation. For example, your users, the one that authenticating from the browser, provision those certificates may be different from, say, provisioning the service certificates which running in the private network behind the proxy. And then you can think about multi-cloud, multi-region deployments, right? You use certificate to authenticate those different regions, or can a service users from one region to be able to authenticate to another service in a different region, even though they run as a separate clouds, but you can trust, you can set up a trust relationship with SSL certificates. And then there's some Keystone limitations that we have to deal with. Right? For example, we have configured that remote ID in Keystone.conf. The remote ID is basically used to identify the service providers. And Keystone.conf only have one global remote ID. And we think those remote IDs should be managed programmatically instead of sticking it to the static config file. Because, to be able to create a service provider, we should not have to reconfigure Keystone at all. It's static. And then currently, use the federation, the mapping can only map you to a unscoped token. Ideally, we want the map to be flexible enough to also map you to a scoped token. Yeah, like I said before, most deployments would have SSL terminate at the proxy or load balancer cluster, and then that connection is forwarded on. That connection would, I'm sorry. The SSL would terminate at the proxy and load balancer, and then that would open up a new connection, which is a HTTP connection or HTTPS to the backend keystones, because most likely the Keystone instances are running in a private network, protected by firewall and so on. And this is an example of what it looks like in a typical deployment. You would have an external VIP, right, which is accessible by the external clients, and then you would have both the admin VIP and the internal VIP would sit behind the firewall. External clients have no visibility to them, and they can only be accessible by the internal controller nodes. And then, it depends on how you want to deploy OpenStack. Most likely, you would have different controller nodes spread across. And then you would have, Keystone in one of the nodes, so you could have multiple Keystone instances, and then you can mix and match the services and so on. If you're going to use HA proxy to front the external VIP, you would have to, let's say if SSL is terminated at HA proxy or at the load balancer, you would have to pass the client certificate information to the headers. So this is an example of the HA proxy configuration. The SSL is terminated at that point. And then those headers would get forwarded to the Keystone backend. And at the Keystone side, what I did in the POC was that I basically translate those headers back to the Apache style environment variables. So this is like a four-man job to translate whatever comes from HA proxy back to the environment variable set, as we normally set by the mod SSL. And then for SSL pass-through, it's pretty simple. You just basically configure your proxy and load balancer to not terminate the SSL connection and just forward it on to the back-end Keystone instance. And like I said, for the hybrid approach, you have two layers of SSL connections. First, the client SSL connection terminates at HA proxy. HA proxy will open up a new SSL connection to the Keystone instance in the back. And then the header will still protected by the new SSL connection. So which means that even if you're insider you log into one of those instances, you will not be able to impersonate an identity by, without having access to the private key of HA proxy. So that's it. So if you guys want to learn more about the stuff that we talk about, and here's the various resources and links that you can follow through. And some of them are pretty basic. You just say Google what is externalized certificate, and we get a bunch of them. And how this certificate-based authentication works, and you get some good resource. And how to configure federation, the first link there. And those can be found in the doc.openstack.org Keystone. Now, if this all sounds good, and you guys want to go back and try all this out, right, and say, hey, it doesn't work. Where can you get help? So both Sam and I and all the Keystone cores hang out at the OpenStack Keystone RC channel, Freedom. And you can also go to the mailing list, and most of us subscribe to OpenStack Dev or OpenStack operators. And if you have a Keystone specific question, don't forget to put the Keystone tag in the subject line. That's where our email filters. We filter Keystone specific emails by that tag. And also, if you can get the answer, you can directly email us through our HP email address.
Hi, Juan. Hey, quick question for you. So you mentioned a couple different times you have mapping mechanisms, they said between the X.509 cert and, I got it right, and unscoped Keystone token. Why can't it be mapped straight to a scoped token right now today? What's stopping you from doing that?
Nothing. Nothing. That's one of my complaints in this slide. Is that this one of my complaints right here. The last point, right? Currently, is open for the mapping. You always will get back an unscoped token, right? There should be a way to allow you to directly map.
I'm just trying to figure out why it is you're only getting back unscoped token now today. That's just what's there currently in the implementation.
Yeah. For one thing, federation is still early in the game in terms of federation. We have to, figure out what other use cases out there, then we can think of a way to enhance it. But I think it's good time now to enhance the mapping to map to a circle.
Well, yeah, it's so rudimentary to just go straight from authentication to authorization. It's like, wait a minute, okay, you're a user, you can do this. But I think with like there's a lot of room for like, what are you going to put in the middle? Okay, so this person is in this group has this role, and
right.
This role allows you to do these things, and you're looking to do this thing here. So you now have this, you would get a token to do a particular thing, having been used a cert to get to a role in the middle somehow. And I think there's a lot of room in there for some exploration of how to connect those two sides together.
Yeah,
but that's part of why I wanted to ask about the scope versus unscope, because I think it's maybe at the heart of the whole thing.
Right, that's essentially what Sam's demo was showing, is that from middleware to Keystone, we validate that token. We basically use the cert to directly authorize that call, right? Authentication, authorization, all in the same step.
So I mean, it's still, it's rudimentary, but it's step one. It's important. I like that. Thank you.
Yeah.
Okay, thanks so much.
Well, thank you.
Any other questions? I'll even walk around. You one chance, so have the microphone brought to you.
Any other questions? All right, so you almost liked it. That was
No, that's it.
okay. So it sounds like you're wrapping up, but I'm not trying to kick you off stage. But I did definitely want to give everybody a chance to give you another awesome round of applause and the Keystone team, which is thank you guys so much. And that might have been our deepest dive, definitely of the year. But if you guys want to contribute to Project Keystone, you can contact these guys. Morgan, also, who you remember has just been elected to the TC. Yay! Our friend Morgan, moving on up in things. But anyway, it's a fabulous project. It's an important project, and the team is a lot of fun. Morgan already picked me about this cycle, and I was trying to get my help on that. So I don't know. If I don't have Alina, then I'm not so sure. And you want to have cupcakes, so.
For Keystone, right? Keystone, they say just like security. When it's working, you won't know it's there. But when it doesn't work, nothing will work.
Yeah, no, it's really important. People know about it. It was the darling of the summit a couple of summits ago. So speaking of the summit, I hope I see you all at the summit. Looks like, given the Tokyo Summit shirt over here, that hopefully we'll see you in Austin. Right? You gonna go? Awesome. Okay, so find us all in Austin. We'll pop into a cloud beers, so check that out. And thanks again. If this was the last meetup in Sunnyvale, it was a really good one. So thanks, Dan, thanks, Mom, thanks, Grace, and thanks you all, and thanks, Alina, and thanks, Rick. It's been so fun. Rick has been doing this longer than I have even. So it's been so great working with you guys. So drive safely, and we'll see you in 1 month on the 12th at VMware. Bye.
I love to